Today let's look at multiplying polynomials, and we're going to start out with multiplying two terms by two terms, which is multiplying a binomial times a binomial. I'm going to show you this with the area model and with distributive property. You can choose whichever strategy you feel more comfortable with. With the area model, I'm going to start out with a rectangle. The reason I start out with that rectangle is because I have two factors. I have a factor of x plus 2 and another factor of 3x plus 5. Whenever I am multiplying two factors, I can always model that with a rectangle. I'm going to divide my rectangle into two rows, and that's because I have two terms in my first factor. I'm going to label those rows as those terms. So I have x and positive 2. Then I'm going to divide this rectangle into two columns, and that's because I have two terms in my second factor, and I'll label those columns 3x and positive 5. Now I'm simply going to multiply each row by each column. So first I'm multiplying x times 3x, which is 3x squared. Next, I'm going to multiply x times 5, which is 5x, and 2 times 3x is 6x, and finally 2 times 5 is 10. One thing that I love about the area model is that now that I have these partial products and I need to combine like terms, my like terms are right on the diagonal. So my final simplified expression is 3x squared plus 11x, and I got that 11x by combining these like terms of 6x plus 5x plus 10. So the simplified expression is 3x squared plus 11x plus 10. Now let me show you the same exact problem using distributive property. Using distributive property, we know that we have to multiply each term in my first factor by each term in my second factor. So first I'm going to multiply x times 3x, which is 3x squared. Next I'll multiply x times 5, which is 5x. Next I'll multiply 2 times 3x, which is 6x, and finally I'll multiply 2 times 5, which is 10. Finally, I have to combine my like terms. My like terms are 5x plus 6x, so my final simplified expression is 3x squared plus 11x plus 10. And I'm also just going to color code the area model with the same colors from distributive property to show you how it's the same exact steps, just one using a graphic organizer. So here I had that 3x squared, which is in red over here. Here I had that 5x, which is in blue here. Then I have my 6x in green, and finally that 10 in yellow. I would like you to try both strategies when you are multiplying binomials by binomials, because when we multiply with more terms, I feel that the area model is a great way to organize yourself. Let me show you a binomial times a trinomial next. Looking at the area model first, for this binomial times trinomial, I'm multiplying x plus 2 times 2x squared plus 3x minus 4. With the area model, I'm starting with a rectangle. I'm going to divide that rectangle into two rows because my first factor has two terms. I'm going to label those rows as those terms. So I have x and positive 2. I'm going to divide my columns into three columns because I have three terms, and label those three columns by my terms. My terms are 2x squared plus 3x minus 4. Now I'm simply going to multiply each column by each row. First, I'm going to multiply x times 2x squared, which is 2x cubed. Next, I'll multiply x times 3x, which is 3x squared. Next, I'll multiply x times negative 4, which is negative 4x. Now I'll multiply my second row by each column. First, I'll multiply 2 times 2x squared, which is 4x squared. Next, I'll multiply 2 times 3x, which is 6x. And finally, I'll multiply 2 times negative 4, which is negative 8. One reason that I love the area model is because now that I have all these partial products, I need to combine my like terms, and my like terms are on the diagonal. I always want to write that trinomial, or polynomial in this case, in standard form with the highest degree first. My highest degree is 2x to the third. Now I'll combine my like terms on the diagonal. 4x squared plus 3x squared is 7x squared. 6x minus 4x is 2x, and I have that constant of negative 8. Now let me show you with distributive property. Again, I need to multiply each term in my first factor by each term in my second factor. First, I'm multiplying x times 2x squared, which is 2x cubed. Next, I'm multiplying x times 3x, which is 3x squared. Next, I'm multiplying x times negative 4, which is negative 4x. And now I have to multiply my second term by each term in my second factor. So I'll multiply 2 times 2x squared, which is 4x squared. 2 times 3x is 6x. And 2 times negative 4 is negative 8x. Now I just have to combine my like terms. Remember, like terms have to have the same degree. So again, just like in the first one, my highest degree, 2x cubed. Now I'm looking for my x squared terms. I have positive 3x squared plus 7x squared, plus 4x squared is 7x squared. Negative 4x plus 6x is 2x minus 8. And I made a mistake here. There should not have been an x in this term. Right here, so negative 8. So I got just the same end result, but I have to say I really feel that the distributive property was a little bit trickier to organize myself. But you choose whichever way you feel more comfortable with.